Hi, Ubiquitous and nice week audiences. I'm Chongyang, a final year PhD at UCL. I will present our work about leveraging activity recognition to enable predictive behavior detection in continuous data. This work was done in collaboration with my fellows Wang and Akhil Mathur, and also with my supervisors Amanda, Nickname, and Nadia. People suffering from chronic pain tend to avoid movements that they fear. As you can see in this video, different movement strategies were adopted by this participant, like stiffness and hesitation. We refer to this as predictive behavior, as people think it can reduce the chance of increased pain or injury. In fact, such behavior leads to more pain and more debilitation. Physical rehabilitation is the mainstream treatment for people with chronic pain, with the aims to reduce their use of predictive behavior and also help overcome fear. This is also aimed to build up their physical capabilities. During the rehabilitation, physios would tailor the support and feedback according to the presence of predictive behavior. Like they would suggest simplification of the field movement, they will also remind them to take a breath when the muscles are too tense. As the rehabilitation is extending to people's daily life outside the clinic, technology should be able to automatically detect predictive behavior in order to personalize the physical rehabilitation. Here, it is a complete data stream of a patient performing a series of activities, like stand on one leg and stand to sit. And this is the majority voted ground truth for the predictive behavior. The task is to detect the presence of predictive behavior in its continuous data. In the past, the backbones for processing movement data have developed a lot in the past few years. At first, recurrent networks were directly applied to the data metrics globally. Later on, networks working on local movement vectors were proposed. Then, the rise of the graph-convolution network showed its effectiveness in modeling skeleton-like movement data. However, directly using those backbones and such continuous data does not promise a good performance, as we can see that the precision recall area under the curve for the binary task is all below the chance level. Thereon, this paper proposes to improve the modeling performances from two perspectives. First factor we can tell from the data side is that is the data imbalance. As we can see, the positive class of predictive behavior only take up for around 21% of the data. Toward this, we combined two successful plugins for loss function engineering that were originally proposed for object detection in computer vision. The first is the focal loss, and the second is the class balance term. We adapted those two for the categorical cross-entropy loss used in this paper. By alleviating the data imbalance during training, the performance improved, but the PR-AUC is still below the chance level. By further looking into the data, an informative evidence for the predictive behavior had been found. That is the activity background. As a result, we propose to contextualize the predictive behavior detection, namely PBD, with activity recognition, namely HAR. And here is the architecture we found to be better for the job, where our preliminary experiments with many different learning frameworks candidates. Now the performance is further improved with the PR-AUC better than the chance level, and the best performance is achieved by alleviating the class imbalance therein. This paper also discussed the impact of sensors number on the performance by testing on the input graphs with different sizes. The performance dropped, but still better than the chance level. We believe with better modeling methods and the hardware designing, the system shall be more efficient for people's daily life. To sum up, the Ubiquitous community working on body movement data that are collected with wearable devices or from visual systems has been focused a lot on the task of activity recognition in the past. Thereon, the research is now moving widely towards the understanding of movement behavior for purposes of healthcare and well-being. In our paper, we bridged the activity recognition and behavior detection, which co-occur in our real life with one altering the other. There are still some limitations about our paper. For example, the activity recognition was not improved with behavior detection, and we look forward to seeing the brilliant minds all over the world for better solution in this direction. Cheers.